I'm Rakesh Chauvin from Sunbeam Sun City. Jai Hind you all. My dear, as you all know that I'm doing the laws of physics in nature. Laws of physics in nature. And you all know that I have already uploaded the video for the law of conservation of charge. Now my dear, today I will teach you the law of conservation of linear momentum and the law of conservation of angular momentum. So first let us start the law of conservation of linear momentum. And I hope everybody in class 11th knows that linear momentum is the word denoted by P, right? P, small p. And this is defined as momentum. Linear momentum is a term defined as mass into velocity, right? Everybody knows that linear momentum is denoted by alphabet P, and what is the definition? It is a product of mass and velocity. In lower classes you call this as momentum, right? But now in 11th you should aware this is linear momentum. Why linear? Because the motion of the body is in a straight line. This kind of a concept, linear momentum concept, when I go for its conservation, they required in a straight line motion. And hence my dear, this law is actually proved by the Newton's laws of motion. Okay, this law of conservation can be proved. All these laws can be proved by the Newton's laws of motion. Right? They are derived from the Newton's laws of motion. So here I am writing, they derive, or you can say it derived from Newton laws of motion. It derived from Newton's laws of motion. Okay. Conservation of momentum, if I supposed to derive, I have to use Newton's laws of motion. All the laws can derive this conservation of linear momentum topic, but I am using Newton's second law of motion to derive this. And I'll show you that linear momentum will conserve. What is the meaning of conserve? That the linear momentum before, right, as in case of charge, that before rubbing and after rubbing, right, in case of charges, before rubbing and after rubbing, the amount of charge was same. And then I said charge is conserved. Similarly, before collision, you can say, when we talk maximum about collision, say before collision the linear momentum and the after collision the linear momentum. Why I said collision? My dear, most of the time you must be observed that when bat and ball get collide, the momentum is conserved of bat and ball. The linear momentum, again linear momentum, because bat and ball move in a straight line. Right, so there, when bat and ball collide, we say it is a conservation of linear momentum. Similarly, striker and coin, carom board, it's also a conservation of linear momentum. Similarly, when bullet fired from a gun, right, is also a conservation of linear momentum. Similarly, a rocket propulsion, that is rocket fired with the help of jet. So that is also linear momentum. But in all these cases, you'll observe the object or a body moving in a straight line. Before and after, the momentum is conserved. Right? Even the collision of car and truck, the collision of proton and neutron, this all where you observe there is a linear momentum. And linear momentum nothing but, Chauvin sir, this is a product of mass and velocity. I mean to say, before the two bodies who are colliding, they are product of mass and velocity before, and after collision the product of mass and velocity remain constant. Right? Again, listen this last word which I said. What is linear momentum? Product of mass and velocity. So the two body, जो दो बॉडी कोलाइड हो रही है, उसका मास और वेलोसिटी का प्रोडक्ट बिफोर, कोलाइड होने के बिफोर और कोलाइड होने के बाद मास और वेलोसिटी का जो प्रोडक्ट होगा, that is same. And therefore then I say the momentum is conserved. Now how I'll prove this? When it will be happen? कब the body has the before also the product mass velocity same and after also the product of mass velocity same come, right? That we have to show, and that is the concept. Okay, so I am deriving it from Newton's law, and say I am taking Newton's second law. Now look at it. According to Newton second law, you all know in class 9th you have done, I'm sure, the rate of change of momentum, right? In class 9th you are talking this as momentum, but in class 11th you will say this linear momentum. The rate of change of linear momentum is proportional. Which proportional? Directly proportional. You all know this line. Everybody know, I'm sure. Directly proportional to the applied force, and denoted by F. Right? This statement is everybody know, and this statement is called Newton's second law, I'm sure. And what is the statement? And I said I'll prove this by using Newton's law. I can prove by first law, second law, third law, all law can prove this. Because when bullet fired from a gun, bullet move forward and gun get backward recoil velocity must be in, we get a jerk at the back. Right? Everybody, all student know. Similarly, when bat hits the ball move forward, bat come backward. Right? So every places you can observe before and after the momentum of this collision is conserved. Right? So now, if I am using this concept, the rate of change of linear momentum, right? Now it is linear momentum. Actually, the one which was given in 9th was not complete statement. It is a linear momentum is directly proportional to the applied force. So here if I write this will be, now how write the rate of change of linear momentum? This can be written as change of linear momentum divided by time. Right? This is actually called rate of change of linear momentum. Right? This rate of change of linear momentum, how can I write down this in this language? So rate means the change of linear momentum will divide by time. So what I did, rate of change of linear momentum को मैं कैसे लिख सकता हूँ? Change of linear momentum whole divide by time. And this is proportional to किसको? This is proportional to what? This rate of change of momentum can be written as change of linear momentum upon time, and this is proportional to what? This is proportional to force. Everybody know? Right. Now, my dear, this I will be taking further. Can I write further? Therefore, this is change of linear momentum. Change of linear momentum whole upon time is equal to kf. You can see, because proportional can be removed where k is constant. Where k is constant. Everybody know k is constant. Because I have to remove proportional sign, so by equality sign I will use constant. And this, let k is equal to 1. Right? That is my assumption. Let k is equal to 1. So what will happen here? Therefore, this is change of linear momentum upon time is equal to f. Right? Now, my dear, the linear momentum is denoted by p. Right? So change of linear momentum can be written as final momentum, that is final linear momentum minus initial linear momentum upon, this is upon time, that is I have written t is equal to f. because change of linear momentum, this term you can see can be written as final linear momentum minus initial linear momentum. If I say change in pressure, that is final pressure minus initial pressure. Change in volume, final volume minus initial volume. So change in linear momentum, final linear momentum minus initial linear momentum upon time is equal to F. Now assume that, my dear, therefore the momentum is generally denoted by P. Let final momentum, final linear momentum is denoted by P. This is therefore minus, let initial linear momentum is denoted by P1. So this is P2 minus P1 upon T is equal to F. Right. So what is P2? Sir, P2 is the final linear momentum. What is P1? Initial linear momentum whole upon, this is T is equal to F. Now here I'll assume, let F is equal to 0. This is very important. This I assume, right now I assume, let F is equal to 0. So what will happen? So here I am writing, what will happen here? Therefore, P2 minus P1 upon T is equal to 0. Why? Because since F is equal to 0, I have taken let F is 0. मान लो F 0 है. तो अगर F 0 है, so P2 minus P1 upon T is equal to 0. So therefore this is P2 minus P1 equal to 0. Because T got multiplied with 0, T into 0 will 0 only. Therefore P2 is equal to P1. What is the meaning of P2? P2 is final linear momentum. Final linear momentum. And what is P1? Is equal to, what is P1? Initial linear momentum. Initial linear momentum. And now I can say thus linear momentum is conserved. So when the linear momentum is conserved, when final linear momentum and initial linear momentum become equal, when the force is 0. अगर ये force 0 नहीं होता, अगर ये F का वैल्यू assume, देखो, see the mathematics, if this F 0 नहीं होता, तो P2 and P1 will not equal. And conservation के लिए the final momentum, linear momentum and initial linear momentum should equal. Then only we can say conserve, na? The charge before rubbing and charge after rubbing. That is initial charge and final charge should equal. Similarly, initial momentum and final momentum will equal only when the force on the body is 0. And this force is called external force. External force. So this is the reason why the law of conservation says that momentum is, and this is why the statement is, when external force acting on bodies, when external force acting on bodies or acting on system, I can say, because now whenever I take two body, one is say bullet, other is gun, right? So this become a system, right? When I say rocket with jet, right, that is one system. When I say striker coin, carom board, that become one system. So here when I say on system, so when external force acting on system is 0, that's very important. Force 0 होना चाहिए. Force अगर 0 नहीं होता, you can see my derivation, you can see for explanation I have given, if this force 0 नहीं होता, तो P2 और P1 equal नहीं होता, you can see. So when external force acting on system is 0, the momentum, which momentum? The linear momentum is said to be conserved. And this example, so my dear, what is important? कब momentum, कब linear momentum body का conserve होता है? right? When there is no any external force acting on me. Then only the momentum before and the momentum after the collision, you can say, is conserved, right? Right, my dear, so take care of this part. When the bullet fired from a gun, the momentum of the entire system is conserved only when there is no other external force apart from bullet and gun, no other external force acting on the system. Am I clear? Similarly, when bat hits the ball, when the momentum is conserved, when bat and ball is only applying the force to one another, there is no other external body who applying the force on ball, otherwise the momentum will not conserve, right? If I said bat is strike the ball and suddenly ball is going with the speed as the bat strike to it, but suddenly if there is an air acting on that ball, then ball velocity will change. So that air which is acting on the ball, so-called air resistance, is an external force. So I have to neglect that concept of external force to keep the momentum conserved. Thank you. So this is about linear momentum, and then I will talk about angular momentum. And so there are so many examples for linear momentum. Any collision between car and truck, collision between bat and ball, collision between striker and coin, collision of the bullet fired from a gun, the rocket propulsion, this all is based on the principle of conservation of linear momentum, which is only possible when the total external force, I write here, when total external force acting on the system is zero. Am I clear? And this is the proof. I have proved it according to Newton's second law, because I said any laws, Newton's laws can derive this, can prove this conservations. So we may take the help of Newton's second law, and I said Newton's second law says the rate of change of linear momentum is directly proportional to force. And then I converted rate of change of linear momentum. How do we write? Rate of change of linear momentum matlab, sir, change of linear momentum upon time. Rate of change of velocity upon time. Rate of change of displacement upon time. So rate of change of linear momentum upon time, directly proportional, I put directly proportional F. Now to remove directly proportional, change of linear momentum upon time, again I have written as it is, directly proportional removed by k, where k is equal to 1, then change of linear momentum upon time is become equal to F. But now my dear, further I went, the change of linear momentum can be written as final linear momentum minus initial linear momentum, because change of pressure can be written as final pressure minus initial pressure. Change of volume can be written as final volume minus initial volume. So change of linear momentum can be written as final linear momentum minus initial linear momentum whole divided by time, that is equal to F. Right. Now let's assume that I have taken some alphabet. Let final linear momentum, any linear momentum denoted by P. Let final linear momentum denoted by P2. Let initial linear momentum denoted by P1. So this is P2 minus P1 whole divided by T is equal to F. And then I said, let the F is 0. So when this F becomes 0, so on the right hand side I will get P2 minus P1 is equal to 0. Right? Because F is 0. I've taken, that's my assumption. That's the point. कि यार अपने को फोर्स को 0 करना पड़ेगा, एक्सटर्नल फोर्स को, तो ये P2 और P1 इक्वल होंगे. Try to understand that. That's a book writing. And therefore you will see in the statement of law of conservation of linear momentum, yes, statement, definitely they have started with this line, when the total external force on the system means car, truck is one system, bat, ball, one system, striker, coin is one system, right? So the total external force acting on the system is 0, that is P2 minus P1 upon T become equal to 0. That's my assumption कि मैंने F को 0 बनाया, and that become a law. कि F 0 होगा तभी linear momentum, initial linear momentum and the final linear momentum will be equal, and if they are equal, the momentum is said to be conserved. So that's what P2 minus P1 upon T is equal to 0, because I have assumed F is 0. So here P2 minus P1, T that multiply with 0, anything multiply with 0 becomes 0. So this is P2 minus P1 equal to 0, therefore P2 is equal to P1, and hence say final linear momentum become equal to initial linear momentum. But this, and then the momentum is conserved. But this is possible. I repeat again and again. This is possible only when the force is zero. I have shown in my equation. And therefore that becomes a statement that when total force acting on the system or bodies is zero, then only the momentum is conserved. That is, then only the final momentum become equal to the initial momentum. Thank you all. Write it down and then I will proceed for the angular momentum. Now my dear, let's begin with the law of conservation of angular momentum, right? Law of conservation of angular momentum. Now my dear, as I said, linear momentum is in the straight line motion. Yeah, I have told you in my previous topic that linear momentum is in the straight line motion. Coin was moving straight line, striker moving straight line, rocket move in a straight line, right? Bat and ball moves in a straight line, right, my dear? So a car, truck was moving in a straight line. So this, the linear momentum which I have given the concept is for straight line motion. And when I talk angular momentum concept, this is for a rotational concept. Rotational concept. Spinning of top. You know spinning of top. You have this one dhora that we there's a toys, right? The chote bacche, they are playing spinning of top. And as dhora is there, they put that rassi and they are throwing like this. And then it is the top, it's moving, spinning, right? Like this at its one point, needle point. So you can imagine, right? Angular momentum conservation. So during the spinning of top, there is a conservation of angular momentum. If similarly, my dear, you must be knowing ballet dancers. Ballet dancers, they are dancing like this, right? They are dancing, they are folding their hand, they are dancing like this they are doing, right? This is the ballet dances they are doing. There also there is a conservation of angular momentum, ballet dances. Similarly, my dear, somersault. Gulati jo hawe mein marte hain, gulati. You can see the somersault, gulati, which is taking place in air, right? That is due to the conservation of angular momentum, that is somersault in air. Gulati marna hawe mein, right? Apne haath pair ko fold karke they are doing like this. Similarly, swimming. When the swimmer diving in a swimming pool, they pull their hand and then they are diving, they are curving themselves and they're diving in a pool. There also there is a conservation, my dear, before diving and after diving. So again, in any conservation, you have to see it before angular momentum and after angular momentum should same. Then only angular momentum is conserved. And the very best example of angular momentum is planetary motion, my dear. So let us take the planetary motion. That will be much better, right? So there is, say, this is the sun. You all know that all the planets revolve in an elliptical orbit. This is the, say, elliptical orbit. Elliptical orbit. This is the lower class answer, that the planet revolve around the sun at the elliptical orbit, and let here there is a sun. There is a sun, and let here there is a planet. I am writing P with the planet, that is planet for P, and S for sun, right? Planet. Now my dear, when this planet is revolving around the sun like this in an elliptical orbit, you can see this planet is at a distance of r, say, from the sun, and the planet is actually, there is a gravitational force. I am writing here F, and in the suffix I have written gravitational. Please take care. There is a gravitational force, my dear, between sun and the planet. And you know, my dear, this gravitational force is actually cause a moment of the planet. The gravitational force between planet, as the planet come here, again there is a gravitational force, Fg, planet comes here, there will be a gravitational force Fg. So always there is a gravitational force between planet and sun, which acts at perpendicular distance from sun to the planet. So what I said, the force acting perpendicular to the distance, force acting perpendicular to the distance produce torque. Try to understand why I am giving this concept. Torque denoted by tau. Look at it, the denotation. It is denoted by tau. And writing is torque. Matlab there the force which is acting, which force is acting on the planet? The gravitational force between sun and the planet. There is a gravitational force, my dear. And this gravitational force acting perpendicular to the distance from the sun to the planet. The distance is the perpendicular distance. This distance is between sun and planet. So this force is acting perpendicular to the distance am I clear? And which produce torque. So what is acting on the planet? Try to understand. What is acting on the planet? Torque is acting on the planet. What is acting on the planet? Torque is acting on the planet. Who provide that torque? Sir, force ने ही provide किया है. But my dear, in linear momentum, force is the word taken care of. Please take care of this, my point. In linear momentum, in translational concept, linear का मतलब translational motion, सीधा motion. So in linear or translational concept, there is a concept of force. है ना? We have taken more effort on force. जब force 0 होगा तो linear momentum conserve होगा. मतलब before linear momentum and after linear momentum same होगा. But my dear, in rotational concept, force actually acting right angle to the distance, that is perpendicular to distance, and it provides torque. So here force is not important for us. Here the torque which is acting on the planet is important for us. Right? So remember this, sometime in class 11th in the chapter number 4, so called as, or in chapter number 4, motion in plane, or in the chapter number 7 we will teach you, better is chapter number 7, rotational motion concept. As far as we are talking straight line motion, there is a force, but as the body move or rotating, there is a torque concept. तो इन शॉर्ट मैं ये बोलना चाहता हूं थ्रू माय वीडियो कि जो काम स्ट्रेट लाइन मोशन में या ट्रांसलेशनल मोशन में फोर्स करता है, वही काम रोटेशनल मोशन में टॉर्क करता है. तो जहां मैंने प्रीवियस टॉपिक में फोर्स को जीरो किया लीनियर मोमेंटम कंजर्व करने के लिए, यहां पर आई विल पुट टॉर्क शुड बी जीरो. बट ये टॉर्क किसने प्रोवाइड किया है? फोर्स ने प्रोवाइड किया है. एंड देयरफॉर टॉर्क का दूसरा नाम है, टॉर्क इज ऑल्सो कॉल्ड as, try to understand, this is very important word. Torque is also called as moment of force. Moment of force. And the formula is F into R. F is the force into R, that is R is the distance. और ये force कैसे लगा है? Perpendicular to the R. Right? And F force acting perpendicular to R, tangential force है. Like this is the force. ये force जो लग रहा है gravitational force है, इसको tangential move कर रहा है. You can see in the diagram. So this F and this R, you can see F and R is perpendicular to each other, produce torque. So हिंदी में समझो, torque moment of force मतलब किसी force ने body में moment लाया. moment of force मतलब force ने मोमेंट ऑफ फोर्स है ना, हिंदी मीनिंग मोमेंट ऑफ फोर्स मतलब फोर्स द्वारा मोमेंट, फोर्स के थ्रू मोमेंट हुआ. सो प्लैनेट पे फोर्स लगा इसलिए उसने मोमेंट किया अराउंड द सन. प्लीज टेक केयर. और कितने डिस्टेंस पे? आर के डिस्टेंस पे, एवरीवेयर. एम आई क्लियर? प्लीज टेक केयर ऑफ दिस पॉइंट कि देयर इज अ फोर्स एक्टिंग ऑन द प्लैनेट एंड इट मोमेंट around the sun, and that force is a gravitational force. It means that moment produced by the force is a torque. Am I clear? मतलब फोर्स के वजह से बॉडी घूम गई, इसके वजह से उसने टॉर्क पैदा कर दिया. Am I clear? टॉर्क एक्चुअली एक्ट हो गया. So my dear here, please try to understand. Torque is also given by the force only. Torque is also given by force only. But it is not only force, it is force multiplied by perpendicular distance. Force multiplied by perpendicular distance. But ये आता किसके वजह से? It is coming because of force exerted or acting on the body. Am I clear? But in previous topic, in straight line motion, there is only a concept of force. But here, force ने moment लाया so that body start moving in a rotational curve, in a circular path. And therefore here there is a concept of torque. Okay. Now after this is all concept I have written here. This is concept. And everywhere you can see there is a force acting. Here is a force and it is a perpendicular distance. Here is a force. Here is a force and it is perpendicular distance. You can see everywhere. Suppose planet is here. There is a force acting at tangential and this is the perpendicular distance. You can see. So everywhere the force is acting perpendicular, right? So what law of conservation says that the rate of change of same जहाँ मैंने now it's easy for you. Where I have written linear momentum, write down angular momentum, and where I have written force, write down torque. So now this will be rate of change of angular momentum is proportional to the torque or tau, denoted by tau, or another name moment of force. So earlier topic it was proportional to force, but now it is proportional to torque, because the torque is actually exist in the topic because body has start taking moment. If my hand is like this, right, and if I move this way, so my hand has taken moment, but this moment is done because of force acting on the hand from the axis. This is my axis of rotation, right, and this is the distance. So here the force acting at perpendicular to the distance, producing torque. Take care. So this is the rate of change of angular momentum is proportional to torque. And there I have written the rate of change of linear momentum proportional to force. So this is the difference between translational motion, that is straight line motion, linear motion, and rotational motion or circular motion. सो वापस से मैं बोलूंगा, इन स्ट्रेट लाइन मोशन जो काम लीनियर मोशन में जो काम फोर्स करता है, वही काम एंगुलर मोशन में, एंगुलर मोशन भी इसको बोलते हैं जहाँ एंगल में मोशन होता है, सर्कुलर मोशन भी बोलते हैं, रोटेशनल मोशन भी है. सो वही काम रोटेशनल मोशन में टॉर्क करता है. एंड नाउ माय डियर, एंगुलर मोमेंटम इज अ वर्ड डिनोटेड बाय कैपिटल एल. So here the rate of change of angular momentum is proportional to torque. So can I write down this as rate of mathematics में mathematically rate of change of angular momentum, right, is proportional to torque. Torque, that is denoted by tau. Now, how I write rate of change of angular momentum? That is nothing but change of angular momentum change of angular momentum upon time, है ना? As I showed, rate of change of linear momentum कैसे लिखते थे? Change of linear momentum upon time. Rate of change of velocity कैसे लिखते हैं? Change of velocity upon time. So rate of change of angular momentum written as change of angular momentum upon time is directly proportional to tau. Say I have taken again here the same concept k. Let k is equal to 1. So that let constant is equal to 1. So it become only tau. It become only tau because constant यहाँ जो आता, that constant is taken as 1. Example. Now, so this will be how I write change of angular momentum, final angular momentum. Similar topic as what I have done earlier. जहाँ वहाँ लिखा final linear momentum. Here I have written final angular momentum minus initial angular momentum. Initial angular momentum, right, upon time t. This can be written this way, is equal to tau, because here it's tau. So that is equal to tau. Right? Change of angular momentum upon time. So change of angular momentum written as final angular momentum minus initial angular momentum upon t, and that is equal to tau. Now this can be written as final angular momentum, any angular momentum denoted by L. So final angular momentum that denoted by L2 minus L1 upon t is equal to tau. And now I assume here let tau is equal to 0, and here I am writing ext at denominator. What is the meaning of tau? Meaning of this? Let external torque, there I have written external force, here I write external torque acting on system is 0. So what will happen with this? Therefore L2 minus L1 upon t is equal to 0. Now this give me, when t get multiplied with 0, L2 minus L1 is equal to 0. Therefore L2 is equal to L1. What is the meaning of L2? L2 is nothing but final angular momentum is equal to initial angular momentum. So when this final angular momentum and initial angular momentum are equal, that's a statement. That's become a statement. So here I am writing the statement here, right? Thus, when total external torque, because tau is 0, टॉर्क 0 हो रहा है तो ही L2 माइनस L1 0 होगा और L2 और L1 इक्वल हो जाएगा, फाइनल एंगुलर मोमेंटम और इनिशियल एंगुलर मोमेंटम सेम हो जाएगा, और तब मैं बोलूंगा एंगुलर मोमेंटम इज कंजर्व्ड. सो व्हेन टोटल एक्सटर्नल टॉर्क टाउ इज इक्वल टू 0, देन फाइनल एंगुलर मोमेंटम is equal to the initial angular momentum. Thus, angular momentum is conserved. So what is important in the topic? Sir, how the torque produce? Who produces the torque? Force producing the torque. Actually, therefore, force produce moment in the body. This is the best example I have given. Say I am moving like this. So this is my axis of rotation and my hand is taking moment like this. So who gives this moment? Force gives this moment. Am I clear? Force produces this moment, and the moment which produced by force is actually measured by a term, is actually measured. जो force ने जो moment पैदा किया है body के अंदर, planet के अंदर, that moment of this planet is measured by the term torque by the formula F multiplied by R, that is distance from my axis जहाँ से body rotate. So I hope you all understood. Thank you very much and Jai Hind you all. Please learn this all. This is very important. This all will be elaborately taught in all other chapters also, but I have tried my level best to give you a superficial idea, little idea, so that you can command on the topic. Thank you and Jai Hind.